In question 3, we're going to do a chi-square test of independence. In this particular problem, we want to test whether being promoted and undergraduate major are related at TMI International. Here is a summary of data that you hypothetically collected. The data is already copied and pasted into Excel. According to the data, 97 people who were not promoted were economics majors. 383 people who were not promoted were other than an economics major. 122 of those who were promoted were economics majors, and 383 were not. The first thing we want to do is we want to total the rows, and then we want to total the columns. And we sum a row or column by typing equals sum, parenthesis, and then highlighting the data. The grand total is the sum of the row totals, or the sum of the column totals, or the sum of the elements. Either way, you get 985 in your sample. To compute the expected frequencies, we take the column total, multiply that by the row total, and divide by the grand total. We do that for each one of these elements. Column total times the row total divide by the grand total. The column total times the row total divided by the grand total. The column total times the row total divided by the grand total. And you know you did it right if the sum of the rows is the same as it is above. 219 versus 219. $766 and $766. $505 and $505. $480 and $480. So we know we did the expected frequency calculations correctly. To calculate the chi-square test statistic, you take the deviation from what we expect. We take the observed frequency minus the expected frequency. We square that difference, and then we divide by the expected frequency. And then we do that for the other three categories. The test statistic is just the sum of those four calculations. And it's pretty small. 2.2208 is pretty close to 0. Now, how do I know if it's small? I got to compare it to the critical value. Why does it appear so small? Well, 97 is pretty close to 106. 122 and 112 are pretty close. 383 and 373 are pretty close. 383 and 392 are pretty close. So the closer these observed frequencies are collectively to their counterparts in the expected frequency table, the smaller the test statistic is. And the more evidence we have in support of the null hypothesis that the type of major and being promoted are independent. So I'm going to copy the test statistic into Cengage now, down here, to 4 decimal places. I need to copy in the expected frequencies one at a time to 3 decimal places. Then I need to copy in the row totals, which again are identical to above here. Then I need to get the grand total, 985. The null hypothesis for this test is college major and being promoted are independent. The alternative hypothesis is that they're not independent. Now, to get the degrees of freedom for the test, we have to take the number of columns, which is 2, subtract 1. Take the number of rows, which is 2, subtract 1. Multiply those two differences. 2 minus 1 times 2 minus 1 equals 1 times 1. So the degrees of freedom is equal to 1. We have a 5% significance level, so we're in column 0.05 in row 1. So our critical value is 3.841. Whoops. Our critical value is 3.841. The degrees of freedom are equal to 1. I forgot to get the total here. To conclude, I have to compare the test statistic to the critical value. If the test statistic is less than the critical value, we have evidence in support of the null, so we cannot reject the null. The test implies that relative to non-economic majors working at TMI, employees who major in economics are equally likely to get promoted. I'm going to check my work, and we should get everything correct. And we get everything correct.